Hello everyone, and welcome back to the Introduction to Python course. And in this case, we're going to be talking about Chapter 3, the decision structures and Boolean logic. Now, in the previous two chapters, we talked about just what programming is and what computers are. We've gone over the basics of that. We've also started going to the basics of the Python programming language. So we've talked about variables, constants, we've talked about comments, we talked about two functions to begin with. We talked about the print and the input functions. So now we're going to go deeper. So we're going to be talking about decision structures because, again, when we're working with any kind of program, you're going to need to make some kind of decisions. And then specifically in this chapter, we're going to be talking about what's called the if statement. We'll also talk about the if-else statement. We'll talk about how we can compare strings in Python, which again are just chunks of text. We'll be talking about nested decision structures. Specifically, we'll also be talking about the if, elif, else statement. We'll also be talking about logical operators, Boolean variables, and bringing back the turtle one more time, we're going to be determining the turtle's state. So again, like I said just a second ago, in most programs, you're going to have to make some kind of decisions. So whenever we're solving problems, whether it's should we hire a person or what kind of result or anything that we're doing, any kind of program we're working on, it's going to have some kind of decision. So to do this, we have what's called control structures. So now there's multiple different types of control structures. And the control structures are just the logical design that actually controls the order in which the statements are executed. Specifically, we have, in this actual lecture, we're going to be talking about two different ones. We have sequential or sequence structure, which is what we've been talking about so far. When we have our print statements or inputs, they always execute from top to bottom in order. So that's just the sequence structure. That's the one we know about so far. And we also have what's called decision structure. So this is where we actually to choose whether we're going to do something or not, depending on whether we meet a condition or not. Okay, so what this looks like is, if we come over here real quick, I should choose draw right here. And if we have our control structure, so we'll do control structure. So the control structure is what chooses how it works. We're basically the flow of the program. And so far we've been, again, talking about sequential. So sequence, sequential, whatever you want to call it. So that's our sequence structure. And now we're talking about what's called decision structures. In the future, we're also going to talk about two other ones, but I'll leave those for a later video. But for now, let's just focus on decision here. So the first decision structure we have in Python is called the if statement. The if statement is just a fancy way of us asking the program a question. If something is true, do it. Otherwise, skip it. So it's basically the same way as if you're asking yourself a question, if it's raining outside, bring an umbrella. Otherwise, don't bring an umbrella. So the if statement is just a true, false, and in our flowcharts, like we'll talk about later, and we'll do an example of that, it's just denoted by a diamond. So we have our if statements denoted by a diamond, and they just only perform the actions that are inside the if statement block if the condition is true. Now this is an example of what's called a single alternative decision structure. What this means is, with the if statement, we only have one other alternate path we can use. We either do the extra stuff in the if statement, or we don't. So it's a single alternative decision structure. So here's an example of the flowcharts. So if it's cold outside, if that is true, then we wear a coat. If it's false, we skip wearing a coat. We just don't do that. So again, with the if statement, we're asking the question, if this is true, we'll do this. Otherwise, we skip it. So in Python, this is what the actual syntax looks like. We have if followed by some condition, which we'll go into these conditions in a second. And after that, we'll have our statements. So that could be print statements, we have our inputs, we have our variable declarations, we have math. Those can all go in those statement blocks there. So the first line of an actual if statement is includes the if keyword. So again, we talked about keywords. You can't make a variable with the name if, because again, it's a keyword. It's if followed by a condition. So we'll talk about the conditions here in a second. And these conditions will always result to true or false. If the condition resolves to true, the actual statements that are indented in the if statement, again, in this case, Python, indentation matters. If the condition is true, the block statements are executed. If the statements are or the condition is false, they're skipped. So the way we do the actual conditions is we use what's called Boolean expressions. So just like with math, if we say is 10 greater than 5, is 10 greater than 5? That resolves to true. And in Python, it's either going to resolve to true or false. So in this example here, we say is a greater than b. If a is equal to 10 and b is equal to 5 with variables, then it will resolve to true. If we say a is equal to 5 and b is equal to 15, it will resolve to false. So this greater than sign here is an example of what's called a relational operator. It's just how we look at two values and compare them. We figure out a relationship between them. So these are the different relational operators we have. We have our greater than, we have our less than operators. That just tests greater than or less than. If the relationship there is true, then it results to true. If it's false, it results to false. If we want to check and see if something's the exact same, so we're saying if 5 is equal to 5. We say equal because, again, it's not the assignment operator, the single equal sign. It is equal. So if 5 is the same as 5, it results to true. But if I say 5 equal 2, it's going to result to false. Because, again, 5 is not equal to 2. We also have our greater than or equal to and our less than or equal to operators, which test more than one relationship at a time. But if either of them exists, then the expression is true. And lastly, if we're trying to see if something is different, we use not equals. So we have the exclamation point for a sort of imagine like a slash in math. So if we were looking at not equals in math, it would maybe look like this. So if not equals in math is that, and Python is just this because that's as close as we can get to that. So it looks like that right there. Okay. So with these different relational operators, we can compare the different things in Python, the different variables, different values, different strings, ints, whatever we want to compare, and we will get either true or false from these. So here's another table of them. So if you're ever confused on it, please go back to this table in the slides or in the video, just to make sure you understand how these relational operators work. Again, if the meaning is true or false, it will resolve to that true or false. So if it says is x greater than y, if x is greater than y and that's right, that is true, then it resolves to true. So the way we're going to do this in the flowcharts is you're going to put the relational operator in the flowchart. So in this case, we're saying is the sales greater than 50,000? So do we make more than $50,000 in sales? If that's true, then let's say the employees get a bonus of 500. So in that case, we're using a rectangle to say we set the variable bonus equal to 500. If we don't, then the bonus is never set and the employees don't get a bonus because it was less than or equal to 5,000 or 50,000, excuse me. So any of these relational operators can be used in a decision block because they always result to true or false. So if you have a decision block, so an if statement, and we'll talk about elif later, if it resolves to true or false, you can use it in a relational operator, in a decision block. Now, it is also possible to have a block inside of another block with Python's if statements. And again, in this case, we'll talk about this in a second here, but indentation matters. So for example, here's a nice example of an if statement. We have our balance is equal to 1,000 and the payment is equal to 1,500. If our payment is greater than our balance, we print that we do not have enough money in our account. And we print your account will be overdrawn. However, if instead of saying balance is equal to 1,000 and payment is equal to 1,500, we flip them, then it won't actually print that. So let's look at this as an example. So if we come over here to our Python file again, we have our mainline logic function here again. So remember, we're going to be using def main, like you see here on the screen, and the if underscore underscore name underscore underscore equals, and then in quotes, underscore underscore main underscore underscore. This is what we're going to use because this tells Python if this is the file we called, we're going to use whatever's in the main function here. Again, we'll talk more about this later, but this is the standard practice in Python. So, like we said before, if we have a balance here, so we'll do balance equals, let's say 2,000, and we have a payment equals, let's say 700. We can have a statement that says if payment is greater than balance, then we'll print you don't, or you do not, or don't have enough money. So in this case, if we do not have enough money, it'll print that. So if we run this now, so we'll do right click, run, we'll run the main, again that's the main.py here. It prints nothing because payment is not greater than balance. Now if I change this from 700 to 2,700 and run that again, it'll say I do not have enough money. So the choice here is, again, with a single alternative decision structure, it's saying if this is true, so in this case 2,700 is greater than 2,000, then we print that. However, if I change this back to 700, like this, then payment is not, which is 700, is not greater than 2,000. Therefore, it skips that print statement that we included there. Okay? Now, one thing to note is that with Python, again, indentation matters. So we have a single tab to be in our mainline function. So everything you put in, every line, every print statement, every input, every variable you have in the main should be indented over 1 to make sure that Python knows that this code or these Python statements belong to the main. So we have one tab there. But when we go inside an if statement, remember, we're going to tab over another time. So if we're inside the main, we have 2 tabs. Now if I go back to our code here, you'll see we have the same thing. We have one tab right here, which is also the same as 4 spaces, so that's one tab there. And here we have 1, 2, 3, 4, that's one tab, 1, 2, 3, 4, that's 2 tabs. And in PyCharm, you'll actually see we have these lines here, right below the if statement, that tell you that that's where that current line is. So now if we're done with the if statement, and we want to go back to the main, we just untab it once. So we'll do another print statement here saying, let's say, done, something like that. So this print statement does not belong to this if statement block because it is only tabbed one time. Everything that is tabbed an extra time from where the if statement is, so this if statement has one tab here. So if we add 1, so everything after this if statement that is tabbed 2 times will be in this if statement. So if we want to have a second if statement, we can untab it, do another if statement here, and we say if balance is greater than 1,000, then we can say you have over $1,000, something like that. So this print statement belongs to this if block, and this print statement belongs to this if block, just like that. So if we run that now, it'll say you have over $1,000 and done. So it does not print this one because 700 is not greater than 2,000. So 700 greater than 2,000 is false, so it doesn't print this. But 2,000 is greater than 1,000, so now we have over $1,000, so we print that one. And then this has no if statement, so we always print that. Now, if we wanted to put something else in this, we can have a second if statement in this. If that's the case, we'd go ahead and tab over. So if we want to put this if statement here inside the other one, we can tab this over and tab that over. And now we have another if statement in there because we add an extra tab. We'll go over this more as we go, but for now just keep in mind that we use the indentation to determine which block or which statements belong to which structure. So one extra indentation means that those statements in this case, these 2 print statements here on the screen, belong to that if statement. They do not belong to the main. Okay? And again here, you'll see we have our sequence structures. Those go one after the other. And we have our decision structures here. Now this last line that we keep on putting starts to make a little bit more sense. We have if name equals main here at the very bottom. What that is doing is when you write a Python script and run it, in the background, Python is actually declaring a variable for that Python file that you initially ran called __name__. And it's setting its value to, you guessed it, __main__. So if I go back actually to our code here and I print __name__, and I run it, you'll see we have that string because in this Python file we called it. So you'll see right here we called main.py. When we run this, it is the main file. So this is checking, all this line is doing is saying if this is the initial Python file that you called, then run the main function. Now this doesn't matter too much right now, but when we get to modularizing our code later in chapter 5, this will become critical. All right, so now we can see here we have our sequence structures and our decision structures. So now we can go ahead and move forward with a little bit of questions here. So let's go ahead and just make sure we all understand this. So if we ask the question, what is a control structure? We can say it controls the order in which the set of statements are executed. So again, that controls the flow of your Python program. If we ask the question of what is a decision structure, we can say it's specific actions are performed only if a condition exists. So again, if condition, so if this is true, do what's in this actual decision structure block. So what is a single alternative decision structure? And what is an example of one? It's a decision structure with one alternative path of execution. In this case, for us, it is the if statement, because it only has one alternative path. We either do the extra code or we don't add that extra code. Now we ask ourselves the question, what is a Boolean expression? So a Boolean expression is an expression tested by if statements to determine if it's true or false. So again, that's the expression we put in the condition block or the condition spot of an if statement to tell whether we should execute the next statement code. So again, we're checking to see, do we execute the code in the if statement block, yes or no, based on that Boolean expression. Now we ask ourselves the question, what types of relationships can we test with relational operators? Remember, relational operators are what we use to compare two values in Python. Specifically, we have access to greater than, less than, equal or equivalency, not equals, greater than or equal to, and less than or equal to. So if we ask the question, how would we write an if statement that assigns 0 to x if y equals 20, then we would get x equals 10, y equals 20, so we just set them to some random values there. Then we say if y equals 20, then we say x equals 0. Now what this is going to do is it's going to say x starts as 10. So we have the shoebox x. We take the value 10, put it in the box, put it on the shelf. We have y now. We say y, shoebox with y, take the 20, put it in the box, put it on the shelf. So now we have two boxes or two variables sitting there. We then say if y equals 20. So we take the box that says y down, that's labeled y, we open it up. What value is in there? 20. Is 20 the same as 20? Yes. So then we say, that's good, that results to true. Then we take that box, put it back on the shelf. We take the X box down, say, okay, we need to change this now because we're doing this code. So we take the 10 out, chuck it in the garbage, and we take a new value, 0, and put it in the box, put the box back on the shelf. After this, we get done with the if statement, so we're no longer in that decision structure. And we do print x. So we take the box down one more time, that's labeled x, open it up, take the value, which is now 0, and print it to the screen. So that is how that code runs. So let's go ahead and try this. So it says, Catherine teaches a science class, and her students are required to take 3 tests. She wants to write a program that her students can use to calculate their average test score. She also wants the program to congratulate the students enthusiastically if the average is greater than 95. We're going to write the flowchart and program that gets 3 test scores, calculates the average, displays the average, and if the average is greater than 95, congratulates the users. So let's go ahead and break this down. So the first thing we need to do is write a program that will get 3 test scores. So we're going to write the flowchart first. So let's go over here to write the flowchart. So we have our start, just like before. So we have start. We have another circle here for end, just like that. We have end. And the first thing we want to do is we want to get input of 3 test scores. So we'll use a parallelogram, put this right in the line here, and we say input 3 test scores. Okay, so we have our 3 test scores there. After that, it says we want to calculate the average, display the average, and then if it's greater than 95, congratulate the user. So we're going to use a rectangle here to calculate the average, calculate average test score. Then we want to do another parallelogram here to print the average test score. And now we get to our actual decision structure in the flowchart. So we'll be using right here with the diamond, we'll click that and we'll say if average is greater than 95, so we put this here, and there's a few parts we need to do. The first part we're going to do is we're going to say if it's true, we're going to use another parallelogram and we're going to print congratulations or congrats, since we don't want to spell it. We're going to go ahead and start connecting, we're about to start connecting these arrows. So we'll start, so once we have this, we'll go ahead and start connecting these arrows. And we're going to start by clicking here again to connect that arrow, click here again to connect that arrow, and then lastly connect this arrow. So we're here. We also want to connect this arrow, but we'll have to start putting some text here now. So we're going to do text and we'll type in true. So if it's true, if it results to true, we'll put this here and we'll say that, grab another arrow here. If it's true, we're going to print congratulations or congrats. We're going to need another piece of text here for false. If it's false, we just go to the end. Now there's one last piece we need, which is another arrow from the congrats here back to where it meets as false here. So we're going to pull this down with this piece, make that look nicer, and there is our flowchart. Okay, so now we have our full flowchart here about we input the test scores, we calculate the average test scores, print the average test scores, and if it's greater than 95, true, we print congrats, false, we just end. So this is how you're going to make your flowcharts with the actual decision structures involved. All right, so now if we want to actually go ahead and write the code for this, we come back over here to our actual pie chart. We can go ahead and get rid of everything here. We don't really need this. So what we're going to do is we're going to first input 3 test scores. That's the first thing we need to do. So we'll say test1 equals input, enter the first test score, just like that. Now because it's a test score, it's going to be a float, so we'll say test1 equals float of test1, just like that. We'll say test2 equals input, enter the second test score. We'll say test2 equals float of test2. And then lastly, we will do the test3. So we'll come down here and we'll say test3 equals enter the third test score. Now again, I'm going to show you just one more time. You don't have to do it. You can do it the same way as you do test 1 and 2, but I'm going to put float around this so I can do a nested function call. So I can just do the, so this line right here is the exact same as these two or these two. It's up to you on how you want to do it. This one is just more compact. Okay. So after we input them, we then go to calculate the average. So then we can say average equals test1 plus test2 plus test3. Noting that each of these is a float value now because we casted it to a float. So we can add them together, put parentheses around this so we make sure we do this first, and then divide by 3. So this makes sure that we do the correct order of operations by adding these 3 together, then dividing by 3 to get a correct average. After that, we will then print out the average. So we'll do print your average is something. Now again, those curly braces are going to be replaced by whatever we put in dot format here. And we'll say average, just like that. So this average right here, whatever's in that value, whatever we calculate from this equation here, will replace both of these curly braces in this string. Now, because we're doing an average here, we might find out that this has too many decimal places, and we'll see that in a second. But if that's the case, we can format it again, just like we did before here, and we'll cover that in a second. Now, getting on to the actual if statement, we can do a comment that says if the user's average is greater than 95, print congrats. So we say if, so we have our if, so again, you see how it turns orange, that is our keyword. Average is greater than, so we use the greater than relational operator, 95, colon, so we put a colon at the end of the if statement, after the condition line here. So just like that, we have our colon right here at the end. Enter, and you'll see we are tabbed in one extra. If you are not, if you're here, make sure you hit tab one time to put yourself one extra tab in, so that you're now inside of the if statement block. Now after this, we're going to go ahead and type in print. I will do congrats, just like that. So what this is going to do now is we take the 3 tests, calculate the average, print the average, and if it's greater than 95, we print congrats. So let's go ahead and try this. So if we run this now, we say enter the first test score. So let's say the first test score we get an 80. The second test score we get an 100. And the third test score we get a 90. So in this case it says our average is a 90, like this. If we run this one more time, and let's say we do 100, 87.312, and then we get a 72. Now our test average is an 86.4. Now this isn't really nice looking, so if we come back up here, we can do, inside the curly braces, we can do colon, dot, 2, F, just like that, and it will take the floating point value we give it, and we'll convert it to just 2 decimal places. So if we run this again, we do 100 again, 87.312, make sure you only have 1 point there, and then the second test score is 72.3. Now it's going to give us just 2 decimal places like this. So now if we want to see this actual print statement here actually run, we need to make sure we get above a 95. So we'll do 100, 100, and 90, or just 90. We'll just do 90 here. So our average is a 96.7, and because that average right here that we calculated is greater than 95, it'll print down here, congrats. So that is how these if statements will work. We will make some value, make a relational operation or a Boolean expression using relational operators to compare a value and a condition. If it's true, we will print something. All right, so that's how this code will actually work. Now, I want you guys to try this. So what we're going to do, what we're going to do is I want you guys to write a program that asks the user for a number in the range of 1 through 7. The program should display the corresponding day of the week, where 1 equals Monday, 2 equals Tuesday, 3 equals Wednesday, 4 equals Thursday, 5 equals Friday, 6 equals Saturday, and 7 equals Sunday. So what you're going to do is you're going to ask them for a number, and depending on that number, it should go through and print out the day of the week. And if it isn't any of those numbers, it should display an error message. So what I want you guys to do is take a moment, pause the video, and try this on your own. See if you understand the basic function of if statements so far, and see what you can do. Once you're ready, go ahead and unpause the video, and I'll go over the actual answer. All right, so did you get a chance to actually try it yourself? So let's go over how we're going to do this. Go back over here, and again, we can make a new file if we want. So if we come in here, we do new Python file, and we'll say day of the week. Just like that, and it'll put it right here for us as well. So we'll start with our mainline logic again, so we'll do def main, and then we'll come down to the very bottom, make sure you have both parts, and we'll do if underscore underscore name underscore underscore equals quotes for a string underscore underscore main underscore underscore, and then a colon at the end, then we'll do main. So this calls the mainline logic function. So from here, what we want to do is we want to first get the user input for a day of the week. So we're going to say day equals input, enter a number between 1 and 7. Just like that. And because it is a number, we're going to say day equals int of day. That'll convert our day string to a day integer, which we can use for comparisons. So now what we're going to do is we're going to say if day equals 1. So if this is equal to 1, where 1 is Monday, we're going to print Monday, just like that. Now, it says it should display an error message if the user enters a number that is outside the range of 1 through 7. What we can do is we can say, before we even go there, we can say if day is greater than 7, print error. We can also say if day is less than 1, print error. We can do it that way. Now coming down here, we can repeat this process for every day. So I'll go ahead and copy it. Make sure I'm down here in line. Paste it. We'll keep going. Just going to paste this for every day, and we'll go back and change them. We have 1, 2, 3, 4, 5, 6. We need one more. 7. So again, you'll see that these are all tabbed one time. We'll say if the day is equal to 1, we'll do Monday, 2, 3, 4, 5, 6, and 7. So if it's 2, we'll say Tuesday. If it's 3, we'll say Wednesday. If it's 4, we'll say Thursday. If it's 5, we'll say Friday. If it's 6, we'll say Saturday. And if it's 7, we'll say Sunday. Just like that. So we up here, we're saying we're checking for error values. And down here, we're going to print the corresponding day given correct input. All right, so if we run this now, so again, going up here, we see we have our inputs, we cast it to an int, check for error values, come down here, and now we're printing the corresponding values given the correct input for 1, 2, 3, 4, 5, 6, and 7. So we run this now, and we're given, let's say, so again, if you see this, we actually called the old file, so we'll go ahead and close that, and terminate that, right-click, and run. This makes sure we run the correct Python file because we have multiple. So if I enter a number between 1 and 7, lets me enter the number 100. So that's invalid. So it prints error because it got to here where it says is day 100 greater than 7, so print error. 100 is not less than 1, so it doesn't print that. And 100 is not equal to 1, 2, 3, 4, 5, 6, or 7, so it doesn't print any of those either. So if I run this again and I print, let's say I enter the number 4, it will not print error or error because 4 is not greater than 7 and 4 is not less than 1. 4 is also not equal to 1, 2, 3, 5, 6, or 7, so the only thing that 4 is equal to is 4, which means it prints Thursday. So as you go through this, you'll see that we have every input covered, so we have 1, 2, 3, 4, 5, 6, 7. We have less than 1 and greater than 7 all covered, so any number the user enters, whether it be negative 52, whether it be 2, whether it be 6, or whether it be 15, all of those are covered with our different if statements. So no matter what we put in, each of the if statements will take care of whatever we put in, which means it is called the single alternative decision structure, because if this condition isn't true, it does not print this. If it is true, it does print that. So again, keep this in mind that with the if statements, we can really control how our code operates so that we can fully determine the best approach for the problem at hand given the input the user gives us. All right, so if we know if statements now, we can actually move on to what's called if-else statements. So let's say you have an if statement, but if it's not that, we want to do something else. So that's what if-else statements are. They are called dual alternative decision structures. So the decision structures with two alternative paths of execution. So if the condition is true, so if that condition results to true, we do the first set of statements in the if statement block. If that condition is false, we go down to where it says else and execute the statements in the else block. So we can say, in this case, if your balance is greater than payment, print payment successful. Else, print your account will be overdrawn. So an example of this, if we go back over here, we can say, let's open up a new file again. So we'll do new Python file, balance payment, let's do that. And in here we can do, again, def main, our mainline logic function. You'll do this a lot, so just get used to it and try to memorize it. If underscore underscore name underscore underscore equals quote underscore underscore main underscore underscore. We do main like that. we'll say payment equals 1,000, balance equals 2,000. So now we can say if payment is less than balance, so if the payment is less than our balance, we can print payment successful. Now we can add to this now with our new dual alternative decision structure by saying else, which means if this is false, so if payment is greater than balance, we can print your account will be overdrawn. So if I run this file now, right click, I go to run, it'll say payment successful because 1,000 is less than balance. However, if I change this from 1,000 to 10,000 and run it, it will now say your account will be overdrawn because 10,000 is not less than 2,000 for balance. And that means that this right here becomes false. And when that becomes false, it goes to else and runs what's in the else block. So this is called a dual alternative decision structure because instead of just including one piece of code if it's true, we now include a piece of code regardless of whether it's true or false. We're just choosing which piece of code we run. So we have two different paths we can choose from. So now in a flowchart, we'll now use this approach. So if it is true, we do what we did before, but instead of the false arrow going straight down afterwards, the false arrow will also have something else added to it. Now note that after the true and false, they both still come back together at the end. So make sure that if you have a decision structure, whether you have a true or false path, they come back together at the end and continue, because with a flowchart, there should be a singular line of flow unless there's a decision or another type of structure, but even after the structure is done, it should come back to a singular line of flow. All right, so this is how this is going to work. If that condition is true, like we just saw, this block of the statement is executed. So over here on the left, if condition, we do these three statements. If the logic is false, then we do what's in the else block right here. After both, just like we saw with this flowchart, no matter whether we do true or false, we jump to right after both the if and else. So here, you'll see we jump right here, right afterwards, and here we jump right after the same way. So it doesn't matter what we do, but if we do if the condition, we do the first block or the second block, doesn't matter which. After we're done with either of those blocks, the one that we're working on, we jump to right after the if statement. So what this means is if I come back here and I do print done, if I do this print statement or this statement, it doesn't matter because it will continue on afterwards with this one. So if I run this again, it does the else and then it prints done. If I change this back to 1,000, it'll print payment successful and then print done. It doesn't matter which one I do, whether it's this one or this one, it'll continue on after this block is done. So moving on, a lot of the times we're going to also need to be able to compare strings. So just like with numbers, we can compare strings using the equal equals and not equal to operators. Okay? So now these string comparison is case sensitive because again, when we compare strings, we are looking not at just the letters or the number or the letters, we're looking at the ASCII values, the way we're actually storing the string in memory. So we're not actually comparing the letters, we're comparing those ASCII values, and depending on which way if they're the same value, then equal is true. If they result to different numbers, then the not equal is true. Okay? We can also use the greater than, less than, greater than or equal to, and less than operator, again, using and comparing the ASCII value of each of them. If the shorter word is a substring of the longer word is greater than the shorter word. So what this basically means is, and I'll show you this in an example here in a second, but depending on how they do greater than or less than, it'll show whether it's a substring of the first one, or it'll also show which one's in alphabetical order. So here's one example of comparing strings. So let's say you have a password manager. So you have a database or you have a website where you have logins. If this is true, then we want to make sure that when they enter the password, it's the same as the other one. Again, case sensitive. So we'll say if your stored password is equal to your true password, you log in, otherwise invalid credentials. Another way to do this is you flip it and you say if they're not equal, you have invalid credentials, otherwise you log in. Now this approach here is a little bit more risky because when we have an else statement, imagine it as a bucket that's going to catch everything else below. Okay? So our if statement, in this case, this is the better approach right here because the if statement is more specific. If this one condition is true, you're logged in. And we want to do that with things like credentials with logins. Else meaning if there's some type of error, if there's the credentials are not the same, if something happens, it's invalid. This one, if something does happen, something that we don't see coming, it'll log you in anyways. So again, be very careful, and you use the if statement condition should be the more specific section, and else is a blanket statement that covers every other case. So here's another one here. So if we're sorting names, we can say name 1 and name 2. Again, we're comparing the ASCII value. So if name 1 is less than name 2, name 1 comes in earlier in the alphabet than name 2. Otherwise, we do the other one. We print name 2 first because name 2 comes before name 1. So here's an example of this. Let's compare these two names. We have Mary and we have Mark. Both M's, their ASCII values for both of them is 77. So what this means is we have 77 and 77. So that's the same so far. We go to the next letter. We have 97 and 97. We have 114 and 114. But when we get here, you'll see K has a lower value than Y, which means that the totals for each of them is this. And now because Mary is greater than Mark, that means Mark comes before Mary in alphabetical order. Now note here that the uppercase letter, so the capital M has a lower value than A. So when we sort the names or sort strings using this approach, as we see right here, this approach, when we sort strings this way, all capital strings, if you have an all capital version, so capital M-A-R-Y, will come before lowercase m-a-r-y. Okay, so just keep in mind that the capitals come first, and then we go A to Z. Okay, specifically numbers, so numbers come first, then capitals, then lowers, and in that order it'll be numbers, capital A to Z, then lowercase a to Z. That's how we store it in terms of ASCII values. You can look up an ASCII value table online if you're a little bit confused on how the values are laid out, but you can use this to compare strings to figure out which order in alphabet they come in. Okay, so let's go ahead and try this a little bit. Let's ask the question, how does a dual alternative decision structure work? So if we ask that question, you can answer with, one path is taken if the condition is true, and the other is taken if the condition is false. Moving on, we can ask the question, what statement do you use for alternative decision structures? Again, we use if statements for single alternative decision structures, and we use if-else statements for dual alternative decision structures. Now, when we write an if-else statement, under what circumstances do the statements that appear after the else clause get executed? So we have our if statement and our if statement block. We have our else statement and our else, or the else clause, if you will, and the else block. So the else block is only executed when the condition that we give at the top is false. So let's look at this here. What would the following code here display? So we have S1 is New York and S2 is Boston. Okay? So we say if S1 is greater than S2, we print S2 and then print S1. Otherwise, we put them in the opposite order. So this is doing the same thing. We are now comparing and trying to alphabetize these strings. So it'll print Boston and then New York, because B, the capital B here, has a lower ASCII value than N, so therefore the B string there comes before, for B for Boston comes before New York. So now that we understand that, let's go ahead and give this problem a shot. It says your company asks you to create a program that assists the user in troubleshooting a bad Wi-Fi connection. Use the following flowchart to create a program that leads a person through the steps of fixing a bad Wi-Fi connection and stops when a solution is found. Here's a couple hints here. We're going to use string comparison to see if the user said yes or no. And we're going to use a Boolean variable, which we'll talk about more in a little bit here, to determine if the future steps must be done or if the problem has been resolved. So here's the actual flowchart. And again, I'm not going to make you guys write this because it gets a little bit crazy here. But what it's going to do is we're going to start and we're going to print the first step. Then we're going to say, did that fix the issue? If it's yes, then we'll just go to the end. If it's not, we'll print the next one, check if it fixed the issue, and continue on. So here's how this is going to look. We'll come over here, and we have a new file called wi-fi_debug.py. Here we have our main line logic, so def main, and then if name equals main. So that makes sure we have that. And the first step we're going to do is we're going to print the first step. So we'll do print, and we'll say reboot the computer. So we'll do reboot the computer. Then after that, we ask if it fixed the issue. So we say input, or we'll say user input, just to make sure we don't clash with any keywords, is equal to input did that fix the issue. We'll say yes/no, like that. That's asking and making sure we say yes or no. So if we say if user input is not equal to yes, which means I didn't enter yes, then we'll come in here and we'll say print the next step. So in that case, we'll say we'll check the condition, check user input, and then we'll print the second step. So the second hip here is going to be reboot the router. So we'll do reboot the router. Then here we're going to ask if it fixed the issue again. So we'll copy this exact line here, just like that. And at this point, what we can do is we can do this again. We can say, check the input again inside of this. So again, we're sort of getting what's called nested. We'll talk more about that in a second. But if we do this, if it's not equal to yes, then we'll print the next step. So we'll do print the third step, just like that. So that's going to be make sure the router and modem cables are plugged in firmly. So we'll do print make sure the router and modem cables are plugged in firmly, just like that. And we'll repeat this process a few times. So we'll ask the user if they fixed the issue again, just like that. And then we'll say, check the user input, just like this. And if it's not equal to yes again, we'll do the next step, which is move the router to a new location. So we'll print move the router to a new location, just like this. We'll just do that. And then we'll ask the user input again to fix the issue. And then lastly, if we do this one more time, if it's not equal to yes, we print the last one. If it's not equal to yes, we print get a new router. So we say get a new router. So this is one way to solve this problem. In this case, again, we're using what's called nested decision structures, which we'll go over more here in a little bit. But this is the most efficient way to actually do this problem. Now, another way we could do this is we could keep track using a Boolean variable, which we'll go over here in a second. But that'll just change how we actually solve the problem. Now, with programming, there is 1,000 different ways to solve any problem. It's up to you on which way you want to do it. It doesn't matter too much on which way you want to do it. The only thing that will really ever change is how efficient your program is. Now, if it's better, if you like the other way better, only smaller programs, then use whatever approach you see fit. All right, so that's this way how we're going to do this one. So now what we're going to do is I want you guys to try this one. So write a program that asks the user for the month they were born in and use this month to print out the birthstones for their month. If their input does not match any of the months, print out an error message. So just like before, we're going to say if it matches it, print this, otherwise don't. So in this case, we can go back to the approach we had before. We don't really have to use the else's just yet. But what we can do is we can use a whole bunch of if statements to do this. Now what I want you guys to do is pause the video here and try this one on your own again. If you guys can understand this one, you're getting on the right track here. If you have any questions, leave a comment on this video, and I'll come back and actually look at it and try to answer it for you. Either that or email me, either one's best. With this in mind, go ahead and try it on your own, pause the video, and come back and I'll work on it with you after you get back. All right, so did you get a chance to try it on your own? So let's go ahead and go through this together. So we're going to go ahead and make another new file. We'll do new Python file, and we'll go birthstone.py. So we'll just do birthstone. And we'll go ahead by start with the mainline logic. So we'll do def main. And we'll say if underscore underscore name underscore underscore equals quote underscore underscore main underscore underscore, and we'll do a colon. We'll do main. So again, this does not change. It'll be the exact same way every time. And what we're going to do this time is we're going to ask the user for the month they were born in. So it's going to be January, February, March, and so on, right? So we're going to say month equals input enter the month you were born in. So with that being said, we want that as a string, and we can say if month equals January, then we're going to print Garnet. We're going to continue on. We'll continue this process for 12 months again. So we'll do if that, keep going. All right, so we have a few here. So we'll do January, we'll do February, so February, like that. Okay, and we'll do amethyst here. Yes, that. So amethyst, March is aquamarine. So March is aquamarine. Then we have April, which is diamond. April is diamond. Then we'll do May, emerald, June, pearl. So we'll do May, she is emerald. June, she is pearl. We have July, which is ruby. August is peridot. So July is ruby. August is peridot. September is sapphire, and October is opal. So come down here, we'll do September, which is sapphire. I missed a P here, so I'll put a P there, so sapphire. And October is opal. Then we have November, which is topaz. And we're missing one more, so it's so close, but we need one more, so we'll copy this one more time. And we'll say if the month is December, then we're going to go ahead and print turquoise. That's about right. Let's check. I must flip those around. So turquoise. Okay, so now we have all of our different months. So if we run this now, and we type in the, again, remember that we want to make sure we're on the right file, so close that, right-click, run. So we enter the month, so we'll say January. So it's going to give us Garnet. Now if we put in something wrong, let's say put in the word none, we run that, it's going to give us nothing out, because that string, the month string, the ASCII value of a string that we put in, which is none, is not equal to any of these, and the only way it's going to be equal to those is if we keep it exactly the same way. So now you might be asking, well, what happens if we put in lowercase January, so January, just like that? Well, nothing happens, because again, it doesn't match this exactly. So what we can do is we can do two things. We can either add to this top one, which we'll talk about here in a second, but for now, what we're going to do is we can go through and copy these and put a second option. So if it's big January or little January, just like that, we can do that for each one of these. So I'm not going to sit here and do all these yourselves, but if you would like to, go ahead and go through and add a second if statement for each of the different months to make sure that if you do this with lowercase January, it'll also catch Garnet. So this is both lowercase and uppercase. You'll have to have two for each one if you want to do that. Otherwise, you can just keep it as the uppercase, but it is a good practice for the user just to do extra if statements for each one of them. Okay? All right, so moving on, we talked about how to do if statements. We talked about if-else statements. If you remember when we did the actual Wi-Fi checker, one of the approaches we used just a second ago was we took the multiple if statements and started putting them inside of another. So here you'll see we have one if statement with another in the next one, another in the next one, and another in the next one. This is what's called a nested decision structure. So what this means is that the first if statement must be true, and then the next if statement will be tested, and the next if statement will be tested, and so on. So the only way this get a new router is ever going to be run is if the user input is not equal to yes 1, 2, 3, 4 times. So if we actually run this program here, and we say, reboot the computer, did that fix your issue? No. Did that reboot the router? No. Did that fix it? No. Did that fix it? No. So then it says get a new router. But if I run this and I say yes at any time, so I do no, no, yes, it stops. Because again, it's not equal. So in this third one here, so we have 1, 2, 3. This is equal, it is equal to yes. So this is false, which means anything else in this block down here, including the other if statement, do not get run. So that's why nested decision structures are very nice, because it can help you isolate down a certain situation. So if the user's input is not equal to yes 4 times, or if you say, is it raining and is it cold? So we say if raining, then inside that you say if cold, then maybe you want to grab a rainproof winter jacket. But if it's just raining and it's not cold, then maybe you just want to grab an umbrella. Okay? So we can use the nested decision structures like that. So this is how they will look like in the actual flowchart. So this is where we get to it's getting to get a little bit more complicated, but that's okay. So in this case, if the salary is greater than or equal to 30,000, and then we say that's true, so we move on to the next if statement. We say if the year on the job is greater than or equal to 2, then we can say that they qualify for a loan. If not, we say false, and it says you must be at your current job for at least 2 years to qualify. And if their salary is not even above 30,000, then we say you need at least 30,000 per year to qualify. This is called a nested decision structure. So these are really critical, and again, but realistically, the biggest point that you need to understand with these is that indentation matters. And you'll hear me say that throughout the actual semester because indentation matters in Python. Other languages, we use things like curly braces and semicolons to control and understand and isolate or just organize our actual code for the actual interpreter or the compiler in that case. But for Python's interpreter, we use indentation. So again, back here, you'll see we have, up here, we have one tab here. So this is one tab or 4 spaces. That's 1. We have 1, 2. We have 1, 2 here. We have 1, 2, 3, which means this code is inside of this if block. We have 1, 2, 3, 4 for this if block. So indentation matters a lot with Python because that is how it determines what goes in what block in the actual code. So here's an example of that right here, where you have your if statements. You have if condition. There's your statement. That's 1 tab. elif, 1 tab, elif, and so on. So now real quick, before we go any further, this is the example of a n alternative decision structure in Python. So I say n because there could be any number of elifs, and what this means is that if we say if the first condition is false, elif, which means we check the next condition, and we go down and we keep checking conditions until we get to the else block. So this is called if, elif, else. So it turns our nested decision structures into something much more easier to understand in human readable form. And we can insert as many elifs as necessary, which is why it's called the n alternative decision structure in Python. So we have single, we have dual, and we have n. So just n for n some number of times. All right, so when we actually do if, elif, or else's, again, indentation matters, so they have to line up. So back here, you'll see we have our if right here. This is lined up with this elif, which is lined up with this elif, which is lined up with the else. These are all line up, and the statements inside should also all line up with each other as well. The way that this is going to work, though, is that they're never actually required. You can do if, else, if, else, if, else. You can do that, but if, elif, else's are a lot easier to follow. So here's an example of an actual grade calculator. We say if the grade is 65, we say if grade is 90, print A. Else, if the grade is 80, print B. Else, if the grade is 70, print C. Else, if the grade is 60, print D. Else, print F. So you can see how we're starting from the left side, and we're slowly working our way to the right. Now, if we keep going with this structure, eventually we're going to hit all the way off the screen. Okay? However, if we use the if, elif, else statements, it looks like this now. A lot easier to understand. It's very compact, very easy to read. And now we don't have to ask the question. We just say if the grade is greater than 90, print A. Elif, so else if the grade is greater than 80, print B, and so on and so on. So it's very easy to read. It keeps things from going off the screen, and it makes everything more compact. So this is the way that it's going to work. The if, elif, else statement, that flowchart is the exact same as the if, else nested flowchart that you saw before. It's just, again, the flowcharts will be the same. The code just looks a little bit more compact. All right, so now that we have our nested decision structures, we have talked about if statements, if else statements, if else statements. We've talked about a lot of this here today. We've gone over a whole bunch. But now we can actually expand our operators. So like we said before, we can say if it's raining, and then we can say if it's cold, but wouldn't it be nice if we could do this at the exact same time? Well, we can with what's called logical operators. These are the operators that allow us to create what's called complex Boolean expressions. So remember, Boolean expressions is what we use in the condition block, but we can make them more complex or more capable by using these logical operators. So we have 3, specifically 4, but we'll talk about 3. We have and, or, and not. So the and operator just takes 2 conditions. So we can say if weather, or we say if it's cold and it's raining. So if A is greater than 5 and B is greater than 10, if both of those are true with an and operator in the middle, then the result is true. If one of them is false, it's false. So that's what it means by and. This has to be true and this has to be true. Both have to be true. So an example of this, if we go back over to Python here, if we go back to Python over here, we go back to, let's open up another one here, so just another example one. So example here, we have our def main again, because we'll always have this. So we'll have def main, which is going to do with if underscore underscore name underscore underscore equals quote underscore underscore main underscore underscore colon main, again, just to make sure we have this set up correctly. If we say if, we'll say age is greater than 30, or we'll say age is equal to 30, and let's say balance is equal to 1,000. So we say if age is greater than, or if age is less than 40, and, so again you see how it highlights this orange, balance is greater than 2,000, then we print you are doing well. So in this case, age has to be less than 40, which it is because it's 30, and balance has to be greater than 2,000, which it's not because 1,000 is not greater than 2,000. So if I run this, it's not going to do anything. However, if I change 1,000 to 10,000 and run it again, it now says I'm doing well because this is true and this is true. All right, so that's how the and operator works. If either of them are false, the if statement condition is false. Okay? Next, we have the or operator. Take that, flip it on its head. If both of them are false, it's false. Otherwise, it's true. Because at least one of them is true, it's true. So if I go back to this example we had again here, and I say if age is less than 40, or balance is greater than 2,000, we can say you're doing well. Now if the balance here is 0, single 0, run that, it'll still say you're doing well because age is less than 40. Now if I change the age here to 50 and run it, nothing prints because age is not less than 50 and balance is not greater than 2,000, so neither of them are true, which means that this entire expression, this entire complex Boolean expression is false. So that's how the or operator works. Again, if one of them is true, the entire thing is true. If both of them are false, the entire thing is false. The last one we're going to talk about is going to be the not, but before we get there, we're going to talk about what's called short circuit evaluation. So if you notice back with these other two, with ands, if either one of them was false, it was false. And with or, if either of them are true, it's true. So what this means is if I have age is less than 30 and balance is greater than 1,000, I have an and operator there. If the first one is false, does it really matter what the second one is? No, because if one of them is false with an and, then the entire thing is false. So what Python does is it takes this and uses it to advantage to increase its efficiency, and if the first thing in the and statement is false, then the entire thing is false. It doesn't even bother to check the other thing. The same thing with or. If the first one is true, it doesn't check anything else because the entire thing is true. So keep that in mind. It's called short circuit evaluation, and it really does help Python increase its efficiency because it doesn't have to check things that don't actually matter. All right, now that only works with the and or operators. Now we move on to the not operator. The not operator basically just flips things. So if you have an expression and you put the word not in front of it with parentheses around that expression, it will just change that from true to false or false to true. So if I come back over here and I put the word not and put this in parentheses, this is before it was false, so it didn't actually run anything, because age is 50, which is not less than 40, and balance is 0, which is not greater than 2,000. So both of these are false, which means this entire thing's false. But if I say not, it means now that it's going to take that false and say is not false, and not false is the same thing as true. Just like how not true is the same thing as false. So not is just a way to flip things around, so just keep that in mind. And it just makes things a little bit more readable, but it also allows you to flip the logic instead of having to rewrite the logic to take into account the opposite case. All right, so given this as an example, we can use these logical operators to check a numeric range. So we can say right here, if we want to be within a specific range, let's say between 10 and 20, we can say if x is greater than or equal to 10 and x is less than or equal to 20, then we can say, hey, we're within a range. If instead we say, if we want to be outside of a specific range, we can say if x is less than 10 or x is greater than 20, then we're outside of range. So remember, when we want to be, if we're checking for being within a specific range, we use and if we want to check being outside of a specific range, we use or. So use and for in and or for outside. Okay? Now moving on, there's another variable type that we haven't talked about, or another data type in Python we haven't talked about. We talked about integers or ints, we talked about floating point values or decimals or floats, we talked about strings or just chunks of text, and the last one we're going to talk about is called Boolean variables, and this is a variable that is just either two values. It's not anything else, it's just one of two values. It's either capital T, R-U-E for true, or capital F-A-L-S-E for false. So true or false. It's represented by a bool, B-O-O-L, data type, and it's commonly used as a flag value. So if you want to see whether you've actually achieved something or not, you can use the Boolean variable set as true or false to determine whether you actually met that variable in the end or not, or that met that condition at the end or not. So let's go ahead and try this. Let's convert the following code to an if, elif, else statement. So how would we do this? Well, we take each of these expressions here. So we say, if number equals 1, print 1. And we take this if here and this else here and push them together. So now we have elif, number equals 2, print 2. And the same thing here, we can combine these two, else and if together, and we leave the last else. So now it will look like this. If number equals 1, print 1, elif number equals 2, print 2, elif number equals 3, print 3, and else print unknown. So that is how we're going to convert this to an if, elif, else statement. All right, so let's try this a little bit more. Let's ask the question, what is a compound Boolean expression? So remember, a Boolean expression is what we give to a standard if statement. And that's what we used before, which is just some kind of two values underneath of, are compared via some kind of relational operator. A compound Boolean expression is a Boolean statement that consists of multiple Boolean expressions combined using logical operators. So now let's go through this. What are the following Boolean expressions resolve to? So if we have true and false with the and keyword, that resolves to false. True and true resolves to true. False and true resolves to false. And false resolves to false. Because again, the only time an and is true is if both are true. Moving on to or, we have true or false, which is true. True or true, which is true. False or true, which is true. And false or false, which is false, because with the or operator, it is only false if both are false. We have not true, that's equal to false, and not false is equal to true. Okay, so if you don't understand that, go back over the truth tables in the previous slides. But again, just keep in mind that when we use these logical operators, they're going to combine some kind of Boolean expressions in certain ways that will make an change or allow us to combine different expressions. All right, so let's explain real quick. So let's ask this question. Let's explain how short-circuit evaluation works with and or operators. So remember that short-circuit evaluation works only with and or operators, and if the first expression with an and following it is false, then it doesn't check the rest of it, because if you have one false, the entire and expression is false. The same thing with or. If we have an or operator, then it checks the first value with the or after it, and if the first one is true, the rest of it's true, because with or, if it's ever true, it's always true. So now let's assume that the variables are a equals 2, b equals 4, and c equals 6. How would the following expressions evaluate? So if we have a equals 4 or b is greater than 2, so is a equal, so is 2, because a here is equal to 2, is that the same thing as 4? No, so that's false. But we have an or, so we're not over yet. Is 4 greater than 2? Yes. So that resolves to true. We have the next one here where 6, so is 6 less than or equal to 6? Yes, it is. So we have an and, so we keep going. And is 2 greater than 3? No, so it's false. We have 1, is 1 not equal to 4? That is true. And is 6 not equal to 3, which is true? So it's true. If we have a, which is in this case is 2 greater than or equal to -1? It is true. And we have an or. So when we have an or here, we don't check the next thing because it doesn't matter. Because again, we have an or. So we have 1 true, so it's true. And then we have is a greater than 2? So is 2 greater than 2? It's not, so it's false. But not false is true. So that's how we're going to do these different expressions. If you don't understand them, again, rewind the video here, rewatch the video, go back over the book, go back over the slides. Just make sure you understand this. All right, so here's what we're going to do. If you guys like gambling, you're in luck here, because what we're going to do is we're going to try this problem here together. On a roulette wheel, the pockets are numbered from 0 to 36. The color of the pockets are as follows. So pocket 0 is green. For pockets 1 through 10, the odd numbers of the pockets are red, and the even number of pockets are black. For 11 to 18, it flips. 19 to 28, it flips again. 29 to 36, it flips again. So we're going to write a program that asks the user to enter a pocket number and displays whether the pocket is green, red, or black. It should display an error message if the user enters a number that's outside of the range of 0 through 36. So let's go ahead and get started. Let's make a new file again. So we'll do new Python file, and we'll type in roulette. And we're going to do our def main again. So we'll do def main, and we'll do if underscore underscore name underscore underscore equals quote underscore main underscore colon. We'll do main again. And then from here, we have our standard setup again with our mainline logic. And we're going to get the user input for the pocket number they want. All right, so here we're going to say pocket equals input, enter a pocket number between 0 and 36. Then we'll say pocket equals int of pocket, because we need to make that into a number. So it's now stored as an integer instead of a string. Now, we can start by checking the pocket. So we'll check the pocket for the right color. So we'll say if pocket equals 0, we'll print the pocket is green. Then we'll say elif, so we have our elif here, pocket is, again, we're looking between 1 and 10, so if it's greater than or equal to 1, and pocket is less than or equal to 10, so here we have 1 through 10, then we need to check if it's odd or not. So now here's the thing. When we're checking whether it's odd or not, we have what we talked about in chapter 2, which is called the modulus operator, okay? So the modulus operator, if I go back to example.py, I'll show you how it works one more time. If I have a number, so let's say I have, we'll print it, and we'll say 10 mod 2. It's the remainder. So if I do 10 mod 2, it's going to give me 0. Okay? If I do 11 mod 2, it's going to give me 1. So a little hint here is when you can use the modulus operator, the percent sign here, to determine something is even or odd. Because if you do, and I'll just go through this and do all of them, I'll do enter down here, we'll do a few of them here. I'll do 1 mod 2, we'll do 2 mod 2, 3 mod 2, 4 mod 2, 5 mod 2, 6 mod 2, and 7 mod 2. So what this is going to do, if I run this, you'll see we get 1, 0, 1, 0, 1, 0, 1. Now you might start to notice a pattern here. When we divide anything by 2, if it's even, there is no remainder. So again, if we do the 2 right here, 4 or 6 here, That means that those are even numbers, and they always return a 0 when we do mod 2. That gives us whether it's if we do anything mod 2 and it's 0, it's an even number. Likewise, if we do 1, 3, 5, or 7, we see 1, that's the output of 1, 3, 5, or 7, because any odd number you divide by 2 will have some kind of remainder. So we can use the modulus operator to determine whether it's even or odd. So if we go back to roulette here, we can say if it's in this range, we can say inside there we say if, so we use a nested one, pocket mod 2 equals 0. So if it's even, we're going to print. So for even pockets in this range, they're black right here. So even number pockets are black. So we'll print the pocket is black. Let me say else in here. We print the pocket is red. So note here that these if-else's right here, this is one if-else block here, and we have our if-elif block here lined up. So we have two different blocks. We have a nested block inside, or a if-else block nested inside of an if-elif block. And you'll see this a lot in different programs. So we can continue down back to the elif block here. So we do elif, we say if the pocket is greater than or equal to 11, and the pocket is less than or equal to 18, just like that. Then we have it flipped now. So we'll take this exact same code, but we'll flip it. So we'll say if it's even now, it's going to be red, and if it's odd, in this case, it's going to be black. So you'll see back over here, if it's even, right here, it's red, odd numbers are black. So now we have our first approach and our second approach. Now here's the thing. We flip back again. So why would we write this code again when we can use the Boolean, the logical operators to extend our original Boolean? So what we'll do is we'll take this, put our first expression in parentheses, and then use or, and then write another one after. So we'll say or is the pocket greater than or equal to 12, and the pocket, or not 12, sorry, 19. So is it greater than or equal to 19, because we stop at 18 here, so 19, and less than or equal to 28. So just like that, and that's in a second one. So what's going to happen here is, again, remember Python does whatever's in the parentheses first. So it's going to check this one first. If this first expression is true, it goes in here because we have an or. If it's false, we check the next one, and if this is true, we go in here as well. Okay? So that takes care of that. So instead of having to write this code again, we just compact this. We can do the same thing down here one more time. So we'll put this in parentheses. We'll do or, again in parentheses here, we'll do between 29 and 36. So we'll say or pocket is greater than or equal to 29, and pocket is less than or equal to 36. All right, so this is a very short piece of code that we've simplified using the elif statements here. And the last thing we need to do, don't forget, is if it's not any of those, we need to do else, and we print that pocket number doesn't exist. Because we want to make sure, again down here, displays an error message if the user enters a number that is outside the range. So this is outside the range because we checked 0, 1 to 10, 11 to 18, 19 to 28, and 29 to 36. So we've checked everything in the range. So if it's not any of those, then the number doesn't exist. All right. So now that we have that, that's the simplest way to do it. But if you're confused on that, let's go ahead and change this real quick. And we'll go ahead and copy this piece of code. And we'll go ahead and do it the other way that may confuse a little bit less people. So the other way you could do it is you can repeat the elif here. We can get rid of the ors here, so now it's not going to be as complex of a Boolean expression. Just like that. And then the same thing here, we'll copy this. We'll paste this down here. And we'll get rid of this first part again. And we'll get rid of the second part up here. So the way I first showed was the first way of showing it. This is the second way. So now we say if it's between 1 and 10 and it's even, it's black, otherwise it's red. If it's between 11 and 18, if it's even, it's red, otherwise it's black. We flip back and we say 19 to 28. If it's even, it's black, otherwise it's red. And if it's 29 to 36, it's even. If it's even, it's red, otherwise it's black. So you can do it either way. It doesn't matter which way you do it. I did it the first way because it was more compact, but if you would prefer to do it this way, you can as well. So if we run this code now, and I enter a number, so let's say I enter the number 17. It says it's black, because if I come up here and I say I'm in this range, so I'm between 11, so pocket's greater than or equal to 11, which 17 is, and less than or equal to 18, which 17 is. Now 17 mod 2 is equal to 1, because it's an odd number, so it prints out the pocket is black. If I run that again, and I enter the number 16, it'll say red because it's in the same spot here, in the same condition, but it's even because 16 mod 2 is equal to 0, because it's an even number, and it says the pocket is red instead. So this code will work, and if I run this again with 0, the first condition is chosen instead because it's equal to 0, so it says the pocket is green. Okay? So this is how you would actually do a roulette wheel in Python, just checking the different pocket numbers and which color it lands in. All right, so that's us trying this. So what I want you guys to do is I want you to try this one now. So it says a software company sells a package that retails for $99, but it gives a quantity discount given according to the following table. So if they buy between 10 and 19 of them, they get a 10% discount. 20 to 49 of them, they get a 20% discount. 50 to 99 of them, they get a 30% discount. And 100 or more, they get a 40% discount. What I want you guys to do is I want you to write a program that asks the user to enter the number of packages purchased, and then it should display the amount of discount, if any, in the total amount of the purchase after the discount. So go ahead, pause the video, try this yourself, and come back, unpause the video when you've tried it, and we'll go over it together. All right, did you get a chance to try that on your own? If not, let's go over it real quick, and I'll show you guys how we would actually go about this. All right, so we'll go ahead and make a new file. So we'll do new Python file, and we'll do discount underscore calculator. We'll do again our mainline logic, so we'll do def main. And then we'll do if underscore underscore name underscore underscore equals quote underscore underscore main underscore underscore. And we'll do main again. This again just sets up a mainline logic. And what we're going to do is we're going to first ask the user. So we're going to ask the user to input the number of packages that they want to buy. Okay, so we'll do quantity equals input, enter the number of packages. We'll do quantity equals int of quantity, because again we need to convert it to a number. And we also need to put the price of them at the top as a named constant, so we'll do price in all caps equals 99. So we have a global constant variable here for later use. So then we come down here and we say if quantity is greater than or equal to 10, so greater than or equal to 10, and quantity is less than or equal to 19, then we say we want to put a discount. But we need to control the discount out here, so we'll do discount equals 0 first. And then we'll come in here and we'll say discount equals 10%, so it's 0.1. We'll do elif again here. We'll do quantity is greater than or equal to 20, and quantity is less than or equal to 49. Then we'll say discount is equal to 0.2. Then if it's between 50 and 99, it's 30%. So then we'll say elif quantity is greater than or equal to 50 and quantity is less than or equal to 99, then the discount is equal to 0.3. And then elif, because again, we don't want to catch all, we want to make sure it's 100 or more. If the quantity is greater than or equal to 100, then the discount is equal to 0.4. So what this will do is we initially set the discount to 0, and then we change it depending on the quantity they have. Now after we've changed the discount, we can come down here and calculate the total price including discount, if any. So we'll say total equals price times quantity, so that's the total price, minus price times quantity times discount. So what this is going to do is you'll take the initial price, multiply the discount by it, and it'll subtract out that amount that we're supposed to discount it by from the total price, which is this right here. Now, if the discount there is no discount, it'll be 0. If there is a discount like 4.4, it'll subtract out 0.4 of that price that we gave. So now we can go ahead and print it out. We'll say print discount, and we'll do the curly braces, and we'll do dot format discount, and then we'll do print discounted total, and then we'll do dot format again with our total here. All right, so if we run this now, come open this up a little bit. If we enter the number of packages, if we enter 5, then it's going to give us $4.95 because 5 times 99 is $4.95 because there is 0 discount. Now, we also want our discount to be a percentage, so we can do in here, we can do %. If we run that again, do 5, it'll say 0.00%. If we want to do .2, we can run this again. We'll do 5 one more time, and now it's 0.00% and $4.95. We'll run this again, and I say, let's say we do 17 packages. Now it's going to be 10%, so this is 10% less than what 17 times 99 is. Okay, if we want to make this is a full price, we can put a $sign out here, :.2f for a $sign. If we do 21 now, it'll give us a full $sign amount and a percentage of discount. So this is how you would actually create a program that gives you the discount based on the number of quantities they purchase. Okay. Again, with your programs, make sure you also add a lot of comments. So we might have another comment here that says determine discount. And then here we might have another comment that says print out the discount and total. Just so we make sure we understand everything that this is doing. Okay. So that's how we would actually make a quantity discount program here as well. All right, so now that we've gone through if statements, if-else statements, and if-else statements, we've also gone through relational operators, logic operators. We can apply this to the turtle that we talked about in chapter 2, its state. So we have the turtle heading function, and it will return the heading of the turtle. So if it's 0, it's pointing to the right, 90, it's pointed a different way, and so on all the way around the circle, just to determine which way it's looking. So we can say if it's pointed, if it's greater than or equal to 90 and less than or equal to 270, we're going to set it to 180 instead. So we can use if statements like that. We can use to check to see if it's visible. So we say if it's visible, hide the turtle. If it's invisible, we're not going to try to hide the turtle again because it's already visible. We can use it to check the pen color. So in this case, we say if the pen color is equal to red, change it to blue. So if it's equal to green, we won't change it at all. We can do the fill color as well. So we can switch the fill color from blue to white, just like that, depending on if it's blue, but if the fill color is red, we won't change it at all. We can check the background color here, same way. We can do the pen size, same way. We can do the speed, same way. If it's not instant, set it to instant. All right, so we can go ahead and try this using program.3-9, which is hitthetarget.py. So we'll come over here to the actual PyCharm, and we'll go ahead and open that file. So we'll go to File, we'll go to Open. And I have this program already on my desktop here. So we'll go to Desktop, Teaching Materials here, and click on hitthetarget.py. All right, so this is the hitthetarget.py file that the book actually builds. And we'll go through this real quick. So this is actually going to say we have our named constants with our screen width, height, target left, Y, width, force factor, projectile, north, south, east, and west. So again, each of these is just constant variables that are not going to change. Specifically, this sets the actual screen parameters. This will set where the target is on the actual screen. We have the target's width. We have the force factor, so that's just an arbitrary force factor, which will come in handy later. We have a projectile speed, so we just go slow so we can see it go. And these are just names for north, which is 90, so the angle of 90 is north. West is 180, south is 270, and east is 0. So coming through here, we start by setting up the turtle, so we have turtle.setup. We hide the turtle. We set the speed to instant. We do pen up, go to the actual spot, pen down. So we're going to draw the target real quick. And all this right here is doing is it's setting a square here. We go back to the center, set this heading to east, and we show the turtle again. And we set the projectile speed to 1, because the projectile speed up here is 1, which means that this is going to make the turtle slow. We then ask the user to enter the projectile's angle and launch force. After that, we calculate a distance, we set the heading, and we go forward. So imagine like a missile being launched with this part right here. Then we check, did it hit or not? So if I run this program here, you can try this. Okay, so we'll hit OK. And here we'll see this is the target we're trying to get to. So we have to enter whether or not we're going to do a projectile angle or not. Do 70. Let's try this one more time. Should we make sure it's side by side here? So run this. All right, so let's say 70 and 8. I think I might have changed something in the code here. Hold on 1 second. It's in line 50 here. I put a 7 there by accident. I'll fix that real quick. All right, let's try this one more time. So we'll come in here, do a 70 and an 8. So here you'll see it comes up to the top, and we missed the target. Now again, you'll see it's not actually keeping it up because again, we are not doing turtle.done. So if we do that and we run this again, so we just pull this over again, just like that. We do, let's do in this case instead, we'll do 60, and we'll do 8 again. The turtle's going there, and we missed. We'll try it again. And we'll do, let's say, in this case, 65 and 9. Okay, we're almost there. We missed it just a little bit more. Now what we can do is if we want to simplify this, we can ask the user with this code that I'm going to go ahead and uncomment, that I added myself, and I say, do you want to try again? If you type in yes, it recalls the main and resets everything. So what I'm going to do is I'm going to run this code now. I'm going to do 65 and 9 again. Over here you'll see it gets to the end. It says, do you want to try again? We'll type in yes. It puts the turtle back at the middle. We'll do 65 and 9.5 instead. Goes up the same line and stops in the middle, and we hit the target. So that's how this actual hit the target.py works. Again, you're using an if statement here, so we're saying if the turtle's coordinates are greater than or equal to target left x, and it's less than the left x plus the width, so it basically says, is it in the x area of that target, so in that square, so it is in this square here, the x-axis of the square, and it's up and down, its y-coordinate inside of the target's y. So it's saying, is it in this area and this area? Okay? So that's how the target.py would work. So what I want you guys to do is I want you guys to try this program here. So enough about the turtle for a second. Try this program on your own and just see if you can do this. So it says, write a program that prompts the user to enter a number within the range of 1 to 10. The program should display the Roman numeral version of that number. If the number is outside the range of 1 through 10, the program should display an error message. The following table shows the Roman numerals for the numbers 1 through 10. So go ahead, pause the video here and give it a try. This is just for practice. And see if you guys can do this. All right, were you able to give it a shot on your own? So this one is going to be very similar to our the month option we had as well. So we can come back here, make a new file again. New Python file, and we'll say Roman numerals. Come in here, and what we're going to use is we're going to use our birthstone.py as an example. Or we can actually use we'll use the birthstone example, but we'll improve it. So let's just copy some of this here. And we're going to go over to Roman numerals, and we'll start our mainline logic. So we'll do def main, and then we'll do our if underscore underscore name underscore underscore equals quote underscore underscore main underscore underscore colon. We'll do main here. And what we're going to do is we're going to say numeral for the user, numeral equals input, enter a number between 1 and 10. So in this case, it's going to be a number, so we'll do numeral equals int of numeral. What we're going to do here is we're going to say if numeral equals 1, just like we did in the birthstone one here. We're going to print I, because that's the number 1 in Roman numerals. Just like over here, you'll see 1 is I. We'll say elif numeral equals 2. We'll print I for 2. So over here we have I, and then 3 is I. So we'll print for 2. Say elif numeral equals 3. We'll print I. We'll do quote I. We'll say elif numeral equals 4. Now this is where it changes. We print, instead of I at 4, we print IV. Again, right here we have IV. And then on 5, we say elif numeral equals 5. We'll print V for 5. And then we keep going, so we have elif numeral equals 6. We'll print VI, so 5 plus 1, so V is 5, I is 1. We have elif numeral equals 7. We're going to print VII. Elif numeral equals 8. We're going to print VIII, so for 3. Then elif numeral equals 9. We're going to print IX, because X is 10. And then elif numeral equals 10. We're going to print X. And then else, if it's none of those, we're going to print error. Okay. So if we run this now, it'll say enter number between 1 and 10. If I enter 4, it'll be IV right here, which is 4. So that's how we're going to do our elif statements there. So again, this is just more practice on how we do if, elif, else statements. And a lot of this decision structure is just understanding the actual flow of these decision structures. All right, so in total, in this chapter, we've covered decision structures, including single alternative, dual alternative, and nested decision structures. We've also covered relational operators, logical operators, and created more complex Boolean expressions. We've talked about string comparisons, Boolean variables, and we also determined the state of the turtle and the turtle graphics. So this covers what we're going to be talking about for the decision structures, and in the next chapter, we'll be talking about repetition structures, or repeating it. So instead of having to copy and paste code a lot like we had to do over here with all these if statements and such here, or any other kind of copying, we can just use instead some kind of repetition, or like repeatedly doing the code without actually having to write it. So thank you for joining me today on chapter 3. And again, keep going, keep learning it, and keep practicing it, because that's the only way you're going to get better. Thank you.